Hello students, welcome to JSM Learn. In this today's video, we are going to learn some of the previous IIT JEE main questions and their solutions from the chapter Structure of Atom and particularly from the selected concepts of Introduction to EMR and on de Broglie concept. So let us see the first question. So here they are giving the first question as the wavelength of photon A is 400 nanometer. So in the question, what are the data is given? So written here, so 400 nanometer first one. So frequency of photon B is provided as 10 to the power of 16 second inverse, and the wave number of photon C is provided as 10 to the power of 4 centimeter inverse. So now they are asking for the correct order of energy of these photons. So to identify the order of energy, firstly all these should be in one parameter. So here I am converting all these remaining B photons frequency and C photons wave number into wavelength. So as we know the formula, mu is equals to C upon lambda. So from that we can write the wavelength is equals to C upon frequency. So as here C is what? Speed of light, which can be 3 into 10 to the power of 8 meter per second. So next mu B is given as 10 to the power of 16 second inverse. So from here on simple calculation will get this as what? 10 to the power of 8 will remain here. So this can be written as 10 to the power 3 into 10 to the power of minus 8 meters. Second get cancelled. So now from here, converting this unit into nanometers, that can be written as 30 nanometer. 30 nanometer. So first one. Now, in case of mu bar C, so here we are converting into nanometer because the first one is given in the nanometer. So if all are in same units, it will be very easy to compare together. So now third case, so wave number of photon C is given. So converting this by using the formula lambda C is equals to 1 upon mu bar C. So 1 upon value is given as 10 to the power of 4 centimeter. So from here, so value is given as 1 upon 10 to the power 4 centimeter inverse. So this can be converted into meters as 10 to the power of minus 6 meters. So on converting this value into nanometer, we can write as 10 to the power of 3000 nanometer, as 1 nanometer is 10 to the power of minus 9. So from that, now you can compare all the three values. So you can see lambda C, which is 1000 nanometer, is very higher comparing to the lambda A, which one is 400 nanometer. 400 nanometer. Now lambda C, lambda A and lambda B is very least value. So now from these, as we know the relation, energy is inversely proportional to wavelength. From this we can write, means the photon which has the least wavelength will have the highest energy. So energy order could be written as what? Energy of B is greater than energy of A and energy of C. So here you can find the option D, which is the correct one for this question. So now let us see the second question, dear students. So we have to identify the incorrect statements from the following. So here they have given 4 statements. Among these which are incorrect, we have to identify from the given options. So now let us see. First one, notation of magnesium they have provided 12 and 24. And 24 is the protons and 12 is the neutrons number they are saying. So but here this 12 indicating as number of protons inside the magnesium atom, but they have given as 24 protons it is considering, which is wrong. So as we identified first incorrect statement, now let us see any are there. The second one, the wavelength of radiation of frequency. So they have provided here frequency and its wavelength they are saying as 6.7 multiplied by 10 power minus 8 meters. So whether this information is correct or not, let us see. As we know, lambda can be written as what? C upon mu. So C is what? Speed of light 3 multiplied by 10 to the power of 8 meter per second upon mu value they have provided as 4.5 multiplied by 10 to the power of 15 second inverse. So on simplification we'll get 3 ones are here 1.5. So on simplification, we'll get this value as 6.66 multiplied by 10 to the power of minus 8 meters. That means approximately it is equal to 6.7 multiplied by 10 power minus 8. That means the given statement is true. Here, according to the options, which we have to identify the incorrect one only. So now, the third one radiation has wavelength lambda 1 and 900 nanometers, and its energy they have provided E1. The other radiation has the wavelength as lambda 2 300 nanometer, and its energy they have given E2. So E1 is to E2. The energies ratio they have given as 3:1. Whether this information true or false, let us see. As we know the information, E is inversely proportional to wavelength. From this data, we can write as E1 upon E2 is equals to lambda 2 upon lambda 1. So lambda 2 value we have here as 300 nanometer, and this one as 900 nanometer lambda 1. So from this we are getting the value as what? 1:3, but not 3:1. That means this is the incorrect statement which we have to identify. So 1 and 3 are here incorrect statements. So now just before going for the fourth statement, let us see the options what they have provided here. So 1 and 3 statements are wrong. So 1 and 3, nowhere they are in combination with fourth statement. So such type of questions, in this type of questions, you have to save your time. So for that, no need of solving this one actually. So why? Because we got 1 and 3 as wrong options. Which one? Option A itself saying the correct answer. So in case if you want me to explain this, now let us see how we are going to solve the fourth one. Number of photons of light, wavelength, lambda value they have provided, and its energy, E they are saying 1 joule, will have number of photons, this one. So as we know the formula, energy is equals to NHC upon lambda. So on substituting all these values, we will surely get as 1 joule. Which one is the correct statement? So that means we no need to solve for this one. So one question is given for you as practicing matter. So now you can see here lambda 1 and lambda 2 wavelengths are provided, and their ratio, energy ratio they are asking. So in the previous question you can see option C case, same method you can use for the practice question, and comment your answer below. Okay. So let us see the next question. Question number 3, they have provided us the data as the work functions of two metals Ma and Mb are in the ratio 1:2 they are saying. So that means work function of metal A and metal B in the ratio 1:2. So from this given data, we can write as what? Work function of metal B can be written as work function of metal A to 2 times. Okay, 2 times. Next, kinetic energies ratio. When these metals are exposed to photons of energy. So photons of energy, they have provided 6 electron volts. The kinetic energy of liberated electrons of Ma is to Mb. So that means both the metals kinetic energy ratio they have provided 2.642 upon 1. So this one is written here. So the work function for work functions of metal A and metal B are respectively they are asking for. So to identify the work functions of metal A and metal B. So as we know the formula of incident light is utilized to eject the electron, and X amount of energy it is providing means to move the electron in the forward direction. As kinetic energy it will be utilized. So from this formula we can write kinetic energy of metal A is equals to, can be written as what? Incident light's energy minus work function of metal A. I am giving the equation as 1. Next one, kinetic energy of metal B can be written as what? Incident light's energy minus work function of metal B. So equation number 2 I am writing. So now from these, if we are dividing the equation 1 with 2, then we can write as, look at the information, kinetic energy of metal A upon kinetic energy of metal B is equals to incident light's energy minus work function of metal A upon incident light's energy minus work function of metal B. work function of metal B. So from the given data, we can write ratio of kinetic energies of both the metals Ma and Mb as 2.642 upon 1 is equals to incident light's energy they have given as 6 electron volts minus work function of metal A upon 6 minus work function of metal B. Now look at it, as per the information we have written, work function of metal B can be written as what? 2 times 2 work function of metal A. Okay. On simplification of all these, we will get the work function of metal A value as 2.29. So approximately it can written as what? 2.3 electron volts. So as from the given information, work function of metal B is 2 times 2 work function of metal A. That means it could be what? 4.6 electron volts. So in the options you can find 2.3 and 4.6 as option C. So like this you can easily solve few of the questions which were given in the previous year. So now let us go for the next question. Here one question is for you for practicing purpose, the surface of sodium. So again based on the photoelectric effect concept. So previously how we have solved, utilize the formula, which one is required for this, comment your answer students. So now here they have given two positively charged particles M1 and M2 have been accelerated across the same potential difference 200 kilo electron volt, same potential difference Q into V is equals to what they have given, 200 kilo electron volt. That is nothing but what? Kinetic energy in case of both the particles M1 and M2 is same, they have provided. Next, the masses they have given as M1 and M2 masses also they have provided, and they are saying for the de Broglie wavelength of M1 will be x times of M2, the value of x is, so what is x they are asking for. So now the given data is mentioned, both M1 and M2 are same potential, that means kinetic energies for both the elements, both the particles is same. So from that now let us solve. As we know the formula, de Broglie wavelength lambda is equal to h upon square root of 2m ke. So in both the particles, for both the particles kinetic energy is same. So from that mass and wavelength relation can be written as what? Wavelength, de Broglie wavelength is inversely proportional to square root of mass of the particles. So from that we can write as what? Lambda of m1 by lambda of m2 is equal to square root of m2 by m1, which one is given to us as 4 upon 1. So that means we will get the value as root 4, which is equal to 2. So that means lambda of m1 is 2 times 2 lambda of m2. So that means here x value is what? We are getting 2. So now let's see. So here the x value is 2. So like this easily you can solve the questions. So thank you all. Follow our channel for more solutions.